Okay, for our next problem, we have how much money should be deposited today in an account that earns 7% compounded weekly so that it will accumulate $10,000 in 8 years. So let's list all of the values that we're going to need to try to think about. So how much money should be deposited today? I don't know. How much? I don't know. That's what we're trying to look for. So P is the thing that we're trying to look for. In an account today that earns 7%, so that's rate 0.7, compounded weekly, so there's 52 weeks in a year, so M is 52, so that it will accumulate, so will, that's future, $10,000 is going to be your A, future value, in 8 years, so N is 8. Now we already know that I is equal to R over M. We knew that N equals M times T, so we can figure out what N and I are. N is equal to 52 times 8, which is 416. I is equal to 0.07 divided by 52. Now this is not going to come out nicely, I'm pretty sure. So I'm probably just going to keep that 0.07 divided by 52 because that's not going to be easy for me to type in there. So we'll just kind of keep it like that. Now because I'm looking for P, if you scroll up to the top of the page, you'll see that the P formula is P equals A divided by the parentheses 1 plus I to the N. So because I'm looking for P, I'm using this formula. P is equal to A, which in my case is $10,000, 1 plus the 0.07 over 52 raised to the 416. So when I type this into the calculator, I want to make sure that I'm doing it correctly. Let's put an extra set of parentheses around the denominator so that 416 stays in the denominator and doesn't try to calculate the top divided by the bottom and then take the exponent. So we're going to go ahead and do that. So 10,000 divided by, and then you're just going to do the purple parentheses and then another green parentheses, 1 plus 0.07 divided by 52. Close your green set of parentheses, then raise it to the, that's the little caret button, 416. Now in my calculator, do you see how it's up high? I have to hit the right key so that it gets out of the exponent. And then I do the last purple parentheses. Now that I've typed that in correctly, I can hit enter, and this P present value is going to give me $5,714.25. I rounded up there because this is what we're going to need to deposit. If you round down to 24 cents, when you compound it, it's going to be really, really close to 10,000, but not quite. So let's interpret what this means. If in 8 years I need to have $10,000, okay, so let's say you know that there's an expense coming up. If you deposit $5,714.25 today, in 8 years, you're going to have the $10,000 you need if you have the 7% interest rate that the bank's going to give you and if they are compounding weekly for the next 8 years. So if you can get that set up, then that's how much you're going to need in your account. So that would be our example for solving for present value. Next, we're going to talk about compounding continuously. Some banks use continuous compounding where the compounding periods increase infinitely. Remember how we had compounding once a year, compounding semi-annually twice a year, quarterly, which is 4 times a year, monthly, which was 12 times a year, weekly, which is 52, daily, which is 365 times a year, hourly, every minute. If you keep making those smaller and smaller and smaller periods, and the number of compounding periods increase infinitely, then you have what we call compounding continuously. Every single moment it's compounding, you're getting a little bit more money. So after 2 years, the balance A in an account with principal P and annual interest rate R in decimal form is given by this following formula: A equals PE to the RT. Now, this e, this natural number e, is an interesting number. The number e has an important significance in lots of things in mathematics and science. It's often called Euler's number. It's not Euler, it's pronounced Euler, named after Leonhard Euler. Now, the number e is defined as 2.71828 and keeps on going forever, okay? This number is an irrational number and never repeats and never stops. So the way we can define this number e is if you have n as a positive integer and you do this formula 1 plus 1 over n to the n, it gets really, really, really close to e. So if n is 1, it turns out when you plug in the formula is 2. When you plug in 2, it gets 2.25. When you plug in 5, it's 2.48. When you keep getting really, really, really large numbers, so down here I plugged in 100,000, I'm getting 2.71827. So this is how that number was calculated, and it just turns out that in nature and all sorts of interesting places, this number pops up, which is pretty cool. And here it pops up in finance. So the big thing that you need to understand is E is a number, not a variable. Okay, number, not a variable. There's a button on your scientific calculator labeled E that we will use instead of actually typing out the approximation. Some calculators look like the button has E and then a caret next to it, or an E to the X. Okay, so there's a couple different ways your button might look, but it's all kind of the same. If you look over at my calculator has an E button that's actually above one of the buttons. It says E to the X. That's the one we're going to be using. So it already starts the caret for you. The formula that we will use is A equals P E to the RT. So let's start our example. A sum of $10,000 is invested at an annual interest rate of 8%. Find the balance in the account after 5 years subject to compounding continuously. So because it's continuous, that's how you know that you're going to use A equals P E to the RT and not the other formulas that we've already used. Okay, so then I need A, P, R, and T. So A is equal to, I don't know, that's what we're trying to figure out. We don't know what it's going to be eventually, so we're trying to figure that out. P is 10,000. R is the rate, 0.8, and it looks like we're doing this for 5 years. So when I plug it in, I get A equals 10,000 E, so that's just the number E, raised to the RT. So the R is 0.08 times T, which is 5. Notice I put this in parentheses because I need both of those things to be up in the exponent. When I type this in the calculator, I start with my 10,000 times, and then I'm going to use this EX button. Now that EX button is in green above my button. So when it's above the button in green, I need to use my green second key. So I press the second, and then I do E to the X, and notice that an E and then a little exponent popped up. In the exponent, I'm going to use a parentheses 0.08 times 5. Now your calculator might be slightly different, but you'll need to figure out how you can type this in the calculator so that you can get the same answer as mine, 14,918 and 25 cents. So that's what we'll be getting after the 5 years of compounding continuously at 8%. And this concludes our lesson on simple and compound interest.